All right, so this function right here that we get to graph now is a cubed root function. So just like our nice lovely square root function, I'm going to go ahead and start. I'm going to graph this using our parent function. So I am just going to start off with graphing the cubed root of x. That's all we're going to do. Now, on this one, I need at least 3 points, and I'll show you the 3 points, but I am going to graph 5, and I think you should graph 5 because it's going to show you a better picture of what the picture really should look like. Okay, so again, I'm just going to kind of remember what we know from the parent function, that we know that 0, when I plug in 0, the third root of 0 is 0. That just means 0 times 0 times 0 gives me that 0. Okay, same thing with the 1. The cube root of 1 is 1. And -1, the cube root of -1 is -1. Now, this is why I don't like just 3 points, because you've got to know the shape of the picture. So if you just see those 3 points, you might think it's a straight line. It is not. So I'm going to graph 2 more points. If you don't graph them, it's okay, but if you don't get the right shape, it's wrong. So you might want to graph them just to help you out. But the only other number that I know the cube root of is 8. So I'm going to use my x for 8. The cube root of 8 is 2. That just means 2 times 2 times 2 is 8. So I'm going to come out here to 8 and go up 2, over here to -8 and go down 2. So that's why I like those last 2 points right there, is because now the picture, you cannot mistake that for looking like a line. It is not a line. It is a nice little cube root function right there. All right. Now, couple things. First of all, this isn't what we were asked to graph. Okay, so this was the parent function. We've already graphed this. They want us to graph this with a -2 in front as our a value. So here's what I would do. You could do this in 1 step, or you could do it in 2 steps. It's probably going to be easier just to put it in as 2 steps, or 1 step. Basically, this -2, it's a vertical stretch and a reflection. But if you just multiply all of your y values by the negative with the 2, it will stretch it and reflect it for you. So all you're going to do is come in and all of these 5 y values, we're going to multiply by a -2 and graph that point. Okay, so this y value right here, that was at -2. So when I multiply by -2 by -2, it gives me 4. That means I go back to 0. Don't start at this one. You go to 0, and it means you're going to go up 4. 1, 2, 3, 4. Again, you could have reflected it over and just flipped it over and said it was 2 away from there and then 2 away from there. And then you'd get a 2, and then you could multiply it by a +2. I think it's easier just to do it 1 step right there. Okay, same thing with this point. This point was a -1. When I multiply -1 by -2, I get 2. So go back to the axis right here and go up 2. 0 is a nice number. 0 times 0 is, or 0 times -2 is still 0. So that point gets to stay right there in the middle. This point, this x value was 1. When I multiply 1 by -2, I've got a -2. So I'm going to go down there. And this last y value was a 2. 2 times -2 is -4. So you're going to go 1, 2, 3, 4 down here. And then, you guys, I hope, are better drawers than I am. I kind of do it too. Let's just kind of do it. I'm going to do it like this and go out like that and kind of curve around and go like that. Okay, that means if you don't want to erase it, kind of at least cross these off so that I know that it's not that green one. If you have an eraser, it might be a little bit nicer if you do just erase all of those lovely green points right there. That was just our parent function. It just helped us to graph those 5 points. Okay, so this is our function. This is what they asked us to graph. Now remember, when we're answering questions, the domain and the range are easy. These are always going to be the answers. So I just gave you 2 test question answers. If it's a cubed root, it's not for the square root, but the cubed root, your domain is all numbers, which we write as -infinity to infinity, and our range is all numbers, -infinity to infinity. Okay, our endpoint. This time it's not an endpoint, it's a turning point. Okay, this is just our h and our k. So notice I'm subtracting 0 under the radical. I'm adding 0. I don't shift it at all left and right. So this just stays where it was at the beginning, that 0, 0. This one, though, double check on this one. So our end behavior, we're looking at the two ends of our domain right here. One end is over here. So remember, this is my x values. These are negative infinity x's over here. These are positive infinity x's over here. So this negative infinity is this end on the left. So what is happening to our y values? I know it looks like it's going straight, but it is slightly going up over here. So it's going to positive infinity. Your y values are going to get bigger and bigger and bigger as you go to the left. Okay, over here on the right, as x goes to infinity, this is this end over here, our y's, notice our y's are slowly going down. You maybe need a better arrow from me for that one. But they're going down towards negative infinity. And then remember, you're only going to fill out one of these intervals. Your function's either going to increase forever or decrease forever. You just got to figure out which it is. We're going to read from left to right. So as we read our x's from left to right, we're just trying to figure out what are our y's doing. Are they going up or down? Well, here it's really easy to see because they drop really quickly right there. They are going down right there. So we're going to cross off the increasing interval this time and say we are decreasing for the entire function, or you can look at your domain from negative infinity to infinity. We're always going to be decreasing on this function. And that is how to graph radical functions.